When it comes to algebra, one of the most important skills to be locked in on is how to solve equations. Now, what I'm going to do in this video is I'm going to break down every type of two-step equation. And it doesn't matter if you get into two-step or multi-step, you're basically just using your inverse operations. One of the first things you need to know is your inverse operations. Most of you already know them. It's just opposite operations. What's the opposite of addition? Subtraction. What's the opposite of division? Multiplication. So you just have your inverse operations here. And that's how you move things from one side to another so that you can isolate the variable, which is your main goal in solving an equation. But a lot of times kids will do okay on these first two, but then they start to struggle or make mistakes on these bottom three. So what I'm doing is I'm going to break down each and every one. If you want to skip through the video to find the ones that you need, feel free to do so. But I'm going to break down each one so that you can tackle whatever type of two-step equation you're introduced to or asked to accomplish. Let's get started with problem number one. In problem number one, what you see is everything here is positive. This is a very basic two-step equation. The reason we call them two-step equations is they take 2 steps to complete. I've got to get rid of the 7, then get rid of the x. And if I can get rid of those two parts, I'll have isolated x. X will be all by itself. So how do I get rid of them? Remember, we just talked about inverse operations. So what is the opposite of adding 7? You simply write minus 7 below it, and that will cancel that term out. So if I'm going to subtract 7 here, think of this as a barbell or a weight, right? If everything's the same on the left side as it is on the right side, which equal is telling us, if we remove 7 pounds on the barbell over here, to keep things equal, we got to remove 7 pounds over here as well. And 19 minus 7 is going to leave me with 12. So now I've got 12 on the right side, but only 3x on the left side. In order to get rid of this 3, we need to know what the operation between 3 and x is. When I say 3x, I'm basically saying 3 times some unknown value of x. So you heard me say times, right? Well, if I'm saying multiplication here, we got to use our inverse operation, divide by 3, divide by 3. Whatever you do on the left, you got to do it on the right to keep things balanced. X is still around, but 12 divided by 3 makes 4. We have found the one and only number we can plug in here for x to make this equation true. Let's check it mentally real quick. Put 4 where x is. 3 times 4 makes 12, and 12 plus 7 makes 19. That's how we check our work to make sure we got the right number. So problem number one, pretty basic, pretty simple. But could you do 3, 4, and 5? After this video, you should be able to tackle them, no problem. Let's go into problem 2. When it comes to difficulty level with problem 2, I don't think it's very much different than problem 1, to be honest with you. I just want to make sure you have an example of each. Here we're subtracting 13, so we've got a negative term essentially. So in order to get rid of minus 13, just like we would on problem 1, the opposite of adding 7 was subtracting 7. Well, what's the opposite of subtracting 13? Adding 13. So that will cancel out. Add 13 to the other side, and now we're at 16 on the right side. 2x on the left. Remember, a coefficient, that's a number in front of the variable. Coefficient of 2 and an x just means 2 times x. What's the opposite of times? Divide. Divide by 2, divide by 2. X equals 16 divided by 2, which we all know is 8. Okay, so now you can do your very basic two-step equations, whether there's addition or subtraction now. Let's go on to problem 3. Here's problem 3. One of the struggles that kids have with problem 3 is that your variable's on the right side, and then you also have a negative m in this case, not a positive m. Okay, I'm going to talk to you about a ghost 1 or a Casper 1. That's this hidden value of 1 that's right there. We just don't show it because if I say x, we should all know that that's worth 1x, because if I don't have a 1 there, we just know it's there, right? We have to assume, or not even assume, we just say there's 1 there, right? Because if I have anything other than 1 in front of x, we would have to show it. 2x, 3x, which means 2 times x, 3 times x. Well, what's 1 times x? 1 times anything is itself, so you don't even need to show the 1, okay? But we have to know, even though it's not shown, it's technically there, okay? Because in this problem, what you're going to see is the mistake a lot of kids make is they'll say there's a positive 7. You need to get rid of positive 7. What's the inverse of positive, or what's the opposite of positive? That would be negative. So instead of positive 7, we're going to say negative 7. Cancels. Take away 7 on the other side. 10 minus 7 leaves me with 3. And a lot of times I'll have kids just bring down m. Whoa, 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 hold your horses. That's not an m. That's a negative m. So you need to bring the negative down as well. Remember what we just talked about. It's a negative what value? There's a 1 right there. So if I put a 1 in, what do I have to divide by? This is negative 1 times m. So opposite times, we're going to divide by negative 1. Cancels. Do it to the other side. And if you get the value of negative 3, you're going to be correct. But if you would have left it as m equals 3, that's different than negative 3. So make sure you don't forget about what I like to call the Casper 1 or the hidden 1. All right, just know when you have no value in front of the variable, it's a coefficient of 1. All right, so negative variables, you got to divide by negative 1 at the end. It will always, all it's going to do is just going to change that value from a positive to a negative. Or if this already was a negative, it would change it to a positive. Okay, let's move on to problem 4. All right, this is problem 4, and if you're looking at problem 1, 2, and 3, we got multiplication, and then we had negative 1 times m, which is also multiplication. On problem 4, you see division, okay? A divided by 3 plus 4 equals 6. So we always want to remove the part that is not attached to the variable first. So notice that we got rid of the 7 first in this case. We got rid of the negative 13 first in this case. We got rid of the 7 in this case. Because you never want to get rid of the number attached to the variable until after you've gotten rid of the constant first. Think of these two as like a dating couple. 2 and x, they love each other, they're attached at the hip. 3 and x, they love each other, they're attached at the hip. So don't break them up until the end. All right, so let's get rid of plus 4. We're going to subtract 4, cancels, take 4 away. Good news is 6 minus 4 is pretty easy. That just gives me a 2. And I've got a divided by 3. A divided by 3. Remember, I just need to use an inverse operation to eliminate that 3. Ask yourself what this bar means. Oh yeah, that means division. So if I'm dividing by 3, the inverse or the opposite of that would be to multiply by 3. And by doing that, you're going to cancel the 3 out of the left side. Don't forget, if you multiply by 3 on the left, you also have to multiply by 3 on the right. So we're going to multiply 2 times 3, giving me 6. So A is equal to 6 in this case. Okay, so we've gone through problems 1, 2, 3, and 4. A little bit of differences in each one. Let's move on to our last one, problem 5, which might look a little intimidating. It's not at all. You got this. All right, in a problem like number 5, you've got a fraction on one side of the equation, your variables on top, as well as your constant. So both x and 6 are above a 5. Our job is to get rid of that fraction right away. Step 1, you got to get rid of this 5. So ask yourself, what have I been teaching throughout this video? What is the opposite? What is the opposite? What is the opposite? Because opposites will cancel. We got to get rid of division of 5 or divided by 5. So the opposite of dividing by 5 is just simply multiplying by 5. These two are going to cancel one another. If I do it on the left, I also have to do it on the right. So I'm going to say parentheses 5, which means 2 times 5, which makes 10. And I'm left with x plus 6, but it's no longer written as a fraction. And now I can just get rid of plus 6 by doing the opposite, which is minus 6. Minus 6, minus 6, and we are left with x equals 4. So now that you've gone through each and every one of these problems, you should be able to tackle any two-step equation sent your way. And then the next thing you're going to be learning in your class is how to do multi-step equations. You're going to have to learn about combining like terms, distributive property, as well as a few other things. But for the basics, once you get the hang of this, everything you're going to be taught thereafter is going to be so much easier. This is not a skill that's going anywhere. It's going to stick around all through algebra and beyond. Study hard and good luck on your upcoming test.